Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 2 on congruence, Lesson 13, Proofs about Parallelograms. This will be the last video in the Unit 2 series. The learning goal in this video is to prove theorems about parallelograms. We have one learning target, and that says that you can prove theorems about the diagonals of a parallelogram. For glossary terms, we have rectangle. This is a quadrilateral with 4 right angles. Next, we have rhombus. This is a quadrilateral with 4 congruent sides. Now that we're done with the introduction, let's go ahead and take a look at the practice problems.
Some people say this is too complicated, but when we invest in our communities and our education, we can solve any problem. Let's start with this one.
Practice problem number 1 says that conjecture a quadrilateral with one pair of sides, both congruent and parallel, is a parallelogram. The first thing they want us to do is draw a diagram of the situation and mark the given information. So I'm going to draw a parallelogram. And then I'm going to mark the information that gave us, which is we have a pair of sides that are congruent. So I'm going to mark the top and the bottom with a single tick mark. And they're telling us those sides are parallel. So I'm going to put the little arrow symbol that we've seen that tells us when lines are parallel. And then I'm going to label the corners so that we can call this A, B, C, D. So here's the diagram of the situation, and it has all the information. It's got the corners marked with letters, it's got the top and bottom marked as congruent, and it's got the top and bottom marked as parallel. Now they want us to restate the conjecture that they gave us at the top, but they want us to do it as a specific statement using the diagram. So we're going to say, in quadrilateral, A, B, C, D. Our first statement is that the sides are congruent. So we'll say AB is congruent to CD. The next thing is that we need to say that they're parallel. And AB is parallel to CD. Now, this is where we get into making it a conjecture. We've already made it specific using the diagram, that's this first sentence. We've named the quadrilateral instead of just calling it a random quadrilateral. We have named the sides that are congruent rather than just saying there is one pair of sides that is congruent. And we have named the specific sides that are parallel rather than just saying there's a pair of sides that are parallel. Now we need to finish the conjecture, so we can say prove that quadrilateral A, B, C, D is a parallelogram. And this is all they've asked us to do. They've asked us to take the generic conjecture that they had given us at the top, use that generic conjecture to draw a diagram with the information that they had given us, and then to use that diagram to rewrite that generic conjecture to now actually have very specific information, like the letter name of the quadrilateral, the letter names of the sides that are congruent, the letter names of the sides that are parallel. And then we go ahead and we finish the conjecture by making the statement that we want proven. I hope this helps you understand it a little bit better. I hope it makes sense to you. But if you do have any questions, please feel free to leave a comment below.
We're going to have so much winning, you'll get tired of winning. You're going to get tired of solving all these fantastic problems.
Practice problem number 2 says in quadrilateral ABCD, AD is congruent to BC. So I'm going to mark that information with a single tick mark. And AD is parallel to BC. So I'm going to put the little arrows to mark these as parallel. They want us to show that ABCD is a parallelogram. So I know that I have AD and BC parallel to each other. If I have, so let's go ahead and write that as the first step. AD is parallel to BC. If AC is a transversal of AD and BC, then angle DAC and angle BCA are alternate interior angles and are congruent. So I can say that this angle here is congruent to this angle here because they are alternate interior angles of two parallel lines. The next statement I'm going to make is that AC is congruent to CA because it's the same line. So now if you look, I have side, angle, side. So that means the two triangles are congruent to each other. By the side, angle, side, triangle congruence theorem, triangle DAC is congruent to triangle BCA. So now that I know the two triangles are congruent, I now know that corresponding parts are congruent. So that means that I can say this angle and this angle are congruent. So corresponding parts of congruent triangles are congruent. Therefore, angle ACD is congruent to angle CAB. Now that I know these two angles are congruent, what I also know is that they are alternate interior angles. Since they are alternate interior angles and they are congruent, therefore, AB must be parallel to CD. And the last part of this statement is that because quadrilateral ABCD has two pairs of parallel lines, it must be a parallelogram. So when we're doing these proofs, we're just taking the information that is given to us, and then we're working step by step. If I know this, then this must be true. Now that I have this new information that must be true, I also know that this other piece of information must be true. And I keep doing these statements until I prove what I wanted. So just to review, we knew that the left side and the right side were congruent and parallel because they told us. Because we knew they were parallel, then we knew that angle DAC and angle BCA were going to be alternate interior angles, which makes them congruent. So now we had side and angle. Then, because AC and CA are the same line, we knew that a line has to be congruent to itself. Now, because of the side-angle-side congruence theorem, we can prove that the two triangles are congruent to each other. Once we've proven the triangles are congruent, that proves that all of the corresponding parts are also congruent, which then allows us to say that DCA is congruent to BAC. Once we know that those angles that we marked in green with the two tick marks are congruent, we know that they are alternate interior angles because they are congruent, which then proves that the top and the bottom must be parallel, because that's the only way we can cut two lines with a transversal and have the alternate interior angles be congruent. And then once we've proven the top and the bottom are parallel, we take the information that we already knew about the left and the right being parallel, and that proves the quadrilateral must be a parallelogram, because that's the definition of a parallelogram. So I hope this makes sense. I hope the diagramming makes sense. I hope making each statement a different color helps it make sense. But you're just taking step by step little bits of information that you have to find new information that must be true, and then taking that new true information and just proving over and over again until you go from what you were originally given to what you were supposed to prove. But if you still have any questions, please feel free to go ahead and leave a comment below. We had one learning target in this lesson. You can prove theorems about the diagonals of a parallelogram. So if you think about that second practice problem, we were able to use parallel lines to then say that the diagonals were transversals of parallel lines, which allowed us to identify alternate interior angles, to identify the diagonals as being the same line, therefore congruent to itself, and be able to use all these things that we know about the diagonals to come up with ways to prove that a quadrilateral was not only a quadrilateral, but also a parallelogram. We are able to use one set of parallel lines and the diagonal to then come up with enough side angle side to prove the triangles are congruent, and then other corresponding parts of the triangles are congruent. So this is kind of what we're talking about here, that you're able to look at the different parts of a parallelogram, look at how the diagonals relate to different parts, identify when these diagonals are congruent, or when they help you prove that the angles they create are congruent, which then help you prove that sides are parallel. This is all wrapped up into proving theorems about the diagonals of a parallelogram. So I hope you have a better understanding of writing proofs. I think having a better understanding of writing proofs then gives you a better understanding of how to solve problems in geometry, because now you really know what those theorems are and how to use them to take a small amount of information that you're given and use it to find bigger pieces of information that are true, which then allow you to solve problems. But if you do still have any questions, please feel free to leave a comment below. If you found this video helpful, I ask that you give it a like. If you want to see more of these videos, then in the bottom left, you'll see another video that YouTube is recommending to you. And if you could, in the bottom right of the screen, you'll see the subscribe button for the channel. It would really help out if you would subscribe. I look forward to seeing you in the next lesson, which will actually begin Unit 3.